Hi viewers, welcome to the third lecture for the online series of lectures of Introduction to Category Theory. Last lecture we studied basics of sets, functions and cumulative diagrams. In this lecture we will try to breach the abstract idea of cumulative diagrams with various other conceptual landscapes by means of a very interesting idea called Olog, developed by the author of the textbook that we are following. For details of Ologs, the interested viewers are referred to the article Ologs, a categorical framework for knowledge representation. By Spivak and Kent, and this article is available in archive.org. Alright. So now let me go straight into the definition of Olog. Olog stands for ontology law. Ontology law. And what is ontology? Ontology is the study of what something is. Let me write it down. Ontology is the study of what something is. Can be anything. And ontology law or Olog, ontology law or Olog is the recordings Olog means the recordings of the results of such a study. The results of such a study. Okay? So this is the formal definition of an Olog. Now, what is the basic goal of an Olog? An Olog is a category. Actually, we'll find the detail how it becomes on how it becomes a category in this lecture. But for this moment, we need to see that an Olog is just a category. An Olog is a category. You all know what it means by category. That models a given real world situation. So I'll provide you with an example of an Olog. Okay, let me draw the Olog first. Example. Okay, and we'll study a bit about. We'll study this Olog, this example of Olog a bit first. So I'm trying to label a box with some text. The meaning of these labels will be clear in a while. I have drawn a box on the left which contains the label and amino acid found in dairy. Dairy means food containing milk, food made out of milk. So, an amino acid found in dairy. So, this is what you have on the left. Slightly on the right, there is an arrow from the box that I will be drawing here. Where I have written arginine. So, arginine is an amino acid, and I'm putting down the label is over the arrow. Then I have another arrow pointing to the right of this arginine box to another box with the label an electrically charged side chain. An electrically charged side chain. Okay. So I'll explain what it means by side chain in a moment. So let me draw the Olog first. And then there is another box down here labeled by an amino acid. Arginine is a special kind of amino acid, but amino acid can be anything, not just arginine. And there is another box to the right of this bottom box that we have drawn right here, which is a side chain. Side chain. There can be many side chains. One of them is of the type called electrically charged side chain. And of course, an electrically charged side chain is a side chain. And an amino acid also has a side chain. Okay, so there is another box here labeled by an amine group, and there is an arrow coming from amino acid to the amine group labeled by gas. And finally, there is another box located at the bottom right of the diagram labeled by a carboxylic acid. Carboxylic acid. Okay. And we have labeled the arrow, the arrow here with S. So this is the Olog that we are going to discuss. Okay, so let me erase this part and draw another thing here. The structure, the chemical structure of an amino acid. So it's not a chemistry class, but so to understand this diagram a little better, one needs to see what the structure of an amino acid is. And here is the structure. Here is the structure of an amino acid. So in the center, you have this carbon, and there are 4 hands coming out of the carbon, meaning that these are not arrows, it's just a balancing. Carbon has 4 valence, 4 valence bonds, and it's attached to the nitrogen, and hydrogen here. So this is called the amine group. This is the amine group. And down here there is something what we call side chain. And to the right there is another carbon, oxygen, nitrogen, and another oxygen here. The carbon has 4 valence bands, everything we check. Hydrogen has only 1 valency, oxygen has 2 valency. This oxygen also has 7 valency. And this is called the carboxyl group. The carboxyl group. Okay? So this is how the structure of amino acid looks like. It has an amine group, it has a side chain denoted by R here, and this box is the carboxyl group. So now get back to the Olog and see what it says. Arginine is a particular kind of amino acid which is found in dairy, that is right. And okay, I forgot the label of these 2 arrows. Let me write them. This is labeled as E's, and this is labeled as with S. Okay. So arginine is an amino acid found in dairy, and arginine, meaning this amino acid, has an electrically charged side chain. Okay. And arginine is also an amino acid, and an amino acid has a side chain in general, and an electrically charged side chain is of course a side chain, and an amino acid has a carboxylic acid, has a carboxylic acid as a carboxyl group here, and it also, an amino acid also has an amine group that you can see here. Okay. So what does this arginine mean here? It means a molecule of arginine. Okay. So now I want you to focus on a part of this diagram that we call a subdiagram, consisting. Okay, so before doing that, let me put symbols for these boxes. An amino acid found in dairy is symbolized by D. Arginine is symbolized by A. Or you can also call it some other label. And it has label E. An amino acid has label X. A side chain has label R. A carboxylic acid has label C. Amine group has label N. Okay. Alright. Now we are considering the sub-diagram of this big diagram here, which is this A, E, X, R. So this is just a part of this big diagram, which we call a sub-diagram. And what does it mean? It means this this diagram tells you that arginine has an electrically charged side chain, which in turn is a side chain here. And arginine, on the other hand, is also an amino acid, and an amino acid also has a side chain. All right, good. Now, okay, let me erase this structure of the amino acid, chemical structure of the amino acid. We don't need it anymore. We just needed it because we needed to understand the structure, to understand this Olog a little more clearly. So I have already labeled that arginine as a molecule of arginine as A, so I'm writing A. Let A stand for a molecule of arginine. A molecule of arginine. Okay. So on one hand, observe that A being an amino acid, A is an amino acid, arginine is an amino acid. A being an amino acid, has a side chain. So whatever we have written down here corresponds to this pattern. Arginine, being an amino acid, has a side chain. So we have gone from this box A to box R, from A to R by this path. Arginine, being an amino acid, has a side chain. On the other hand, arginine has an electrically charged side chain, has an electrically charged side chain, which is of course a side chain. An electrically charged side chain is of course a side chain, which is of course a side chain. Okay. So this is what we understand by this sub-diagram. And an amino acid, and a molecule of arginine being an amino acid has a side chain. This is the path from A to R. And an arginine has an electrically charged side chain, which is in turn a side chain. This is the path from A to R again, a different path from A to R. Okay. Now it's important to note that, let me erase this big diagram, the Olog itself. We don't need it anymore. It's important to know that, so we seem to have two side chains in the picture, right? Two side chains in the diagram. but you see that they correspond to the same physical thing, okay? Because they are both the same side chain, which is precisely an electrically charged side chain. Alright? So what does this commutative diagram tell you? This commutative diagram tells you that the result of going from A to R is the same for both the paths. Okay? So in general, okay, we seem to have side chains in the diagram. They correspond to the same physical thing. They correspond to the same physical thing. Alright? And the two paths from A to R are deemed equivalent, are deemed equivalent. Alright, so far so good. Now, this may sound obvious to you, but what is obvious is the most essential, right? So we need to study the obvious things a little more in detail to understand the defects. Alright? Okay, so now that you have an idea of what an Olog means, we move further into this construction of this Olog as a category. We really need to understand why and how an Olog is a category. But before that, we need some terminologies associated with an Olog. So let me write them down here. Some important terms. Some important terms. Well, I say that it's better to call it, constituents to be more precise. Constituents to be more precise. Relative to a given Olog. Relative to a given Olog. And there are types, aspects, and facts. There are three terms here: types, aspects, and facts. We need to understand it. Let me start with types. You saw that in the previous Olog, we had different boxes, and we labeled those boxes with some text, okay? Those boxes were types, okay? So let me concretely define what it means by types. A type is an abstract concept. It is important for you to understand that this is very abstract. You cannot replace these types with some concrete ideas right away, but we eventually would be able to do that by means of a function. But for the moment, you can see that a type is an abstract concept. A distinction. The author. Who is the author? Author is the creator of the Olog. Okay? He or she is the author who creates the Olog. So a time is an abstract concept, a distinction the author has made. Okay. Okay. So we'll come back to the rest of the lecture in a couple of minutes. Thank you for watching the first segment.